9, section 6. This is our last section of chapter 9. Today we're taking a look at solving non-linear systems of equations, and all of the tools and techniques that we've learned so far in chapter 9 are going to come into play in this section. So first of all, a non-linear system of equations may consist of a quadratic equation or other non-linear equations. When a system consists of one linear equation and one quadratic equation, there are three possible outcomes. So this is very similar to what we saw when we had the solutions to a quadratic equation. There was the possible outcome of no solutions, one solution, or two solutions. So let's see what it means to solve a system of non-linear equations. Example 1 says to solve this system by graphing. And this is a really straightforward, nice, easy example. We're just going to throw these two equations into our graphing calculator. And if you remember from earlier in the year, the solution is the intersection points. So we're going to look to see where these two graphs intersect. So we've got these two equations plotted already in Desmos. Here's the first one, y equals x minus 1, our linear equation. And the other one is x squared minus 6x plus 5. So you can see they intersect here at the point 1, 0, and the other point 6, 5. So if we were to graph these guys out, I'm going to just plot a few points, and we'll graph those lines. And so let's see if we can get that straight line through those points there. That's pretty good. And then we had a parabola that had a vertex at 3, negative 4. We're going to plot that guy there, and it passes through here and here. So we'll just try to draw that parabola as best we can. And I missed a little bit, but not too bad. Here's one intersection point. So one solution here is at the intersection point 1, 0. And the other one, I can't remember what it was. Oh yeah, 6, 5. So we were pretty far off. So we need to redraw our parabola so it comes out just a little bit wider, and we get that point 6, 5. So those are our two solutions. Now notice the solutions to a system of nonlinear equations are actually ordered pairs. They're not just the x value. All right, let's try another one now. We're going to use a different technique known as substitution. So you actually practiced substitution earlier in the year, and it's very similar. So it says solve the system by substitution. We see that they're both equal to y, so I can let negative 4 go into this equation for y. So I have the equation negative 4 is equal to x squared plus 4x. All right, now I'm going to get this quadratic set equal to 0 by adding my 4 over. And so now I have 0 is equal to x squared plus 4x plus 4. So a couple of things we can do from here. We can actually do quadratic formula. We could do completing the square. But the easiest thing here is actually to factor this, and because this is a factorable polynomial. So we've got factors of this positive 4 that add up to equal positive 4. Oops. And that's 2 and 2. So my two factors will simplify to x plus 2 times x plus 2, and these guys are set equal to 0, so my solutions are x equals negative 2, and the other one is going to be the same, x equals negative 2. Now we're not done yet, right? We only found the x value. We still need to take this x value and plug it back up in to our equations to find out what our y is. Now this is a nice easy one here because actually they tell us what y is. They tell us that y is equal to negative 4. So our actual solution is the ordered pair negative 2, negative 4. All right, now there's only one solution here, and because there's only one solution, what the graph of that will look like, let's just graph that because this is kind of fun and exciting. So let's graph that horizontal line. We got y equals negative 4, and the other equation was y equals, we had x squared, and then it was plus 4x. So you can see here that that touches in just one point, and there is our solution. All right, so you can always check your answer by going to the graph and graphing out that system of equations, but you should definitely know how to do these methods or these techniques like substitution, and the next one we're going to talk about is elimination. Let's do one more here with substitution. We've got y equals negative 5x, y equals x squared minus 3x minus 3. So we're going to substitute this negative 5x in for that y. We got the equation negative 5x is equal to x squared minus 3x minus 3. Now we're going to add this 5x over, and we're going to combine it with the negative 3x. So our equation is x squared plus 2x minus 3 is now equal to 0. So again, a couple of things we could do. We could use the quadratic formula from here. We could complete the square. But honestly, the easiest thing to do is look and see if it's factorable. We've got factors of negative 3 that combine to be positive 2. That is a positive 3 and a negative 1. So our factors here are x minus 1 and x plus 3, which means our solutions, our zeros here, our solutions are when x equals positive 1 and when x equals negative 3. Again, keep in mind, we're not done yet. We have to take these x values and plug them back in. Let's just plug them into this bottom equation here. This bottom equation tells me what y is equal to. It says y is equal to negative 5 times whatever x is. So when x is 1, my y is negative 5. So there's one solution, 1 comma negative 5. And then the second solution here is when x is negative 3, so negative 5 times negative 3, oh, that's positive 15. So the other solution is negative 3 comma positive 15. Once again, if you were to graph this system of equations, you would see that those two graphs intersect at these two ordered pairs. All right, we're going to do one more example here, one more strategy, I should say, and this is the strategy of elimination. So when we eliminate, remember we're trying to eliminate one of those variables. All right, so you can see that we have a 2x that's in both of these, and we have a y in both of these. So I'm going to eliminate by subtracting right away. So y minus y is equal to 0. X squared doesn't have anything to subtract from, so it's just x squared. And I have 2x minus 2x. So that goes to 0x. Now, I don't really need to write that, but I'm going to, just so you know that those x's eliminate themselves. And then we have negative 5 minus a negative 1. So that's negative 5 plus a positive 1 there, which gives us negative 4. All right, so the equation we have by doing elimination is 0 equals x squared minus 4. Now I can solve. I have no linear term, right? I have no x term. I'm just going to solve using square roots. So I'm going to add that 4 over, and now x squared is equal to 4. Take the square root of both sides, and x is equal to both positive and negative 2. So keep in mind, we're not done yet. We got to take this x, and we're going to substitute it back into one of our original equations. I'll substitute it into this bottom one to find out what our y's are. All right, so y is equal to 2 times, let's use the positive 2, minus 1. That's 4 minus 1, which is 3. All right, so that means one of my solutions, we'll write this down here, is the ordered pair 2 comma 3. We're going to plug the other one in here. We got 2 times a negative 2 minus 1. That's negative 4 minus 1. That's negative 5. And so my other solution here is the ordered pair negative 2, negative 5. So let's just confirm that on Desmos. We'll go ahead and we'll graph those two equations. Get these guys out of here. Y equals 2x minus 1. And the other equation was y equals x squared plus 2x minus 5. All right, and you can see those 2 points of intersection are 2 solutions. There's negative 2, 5, and the other one here at 2, 3. And that confirms what we found algebraically. All right, guys, that's it for your notes for Chapter 9. Let's try this last example 5 here on your own using the technique of elimination that we just showed you, and you can check your work on your graphing calculator.